At Chevron, safety is a core value. Working with DataRobot, Chevron can deploy AI decision-making at the edge to reduce risk to workers and enable safer, more efficient operations. Worldwide, Chevron uses aerial and terrestrial robots to inspect and monitor equipment for abnormal conditions. However, each robotic mission still requires operator verification of safe conditions, which slows response time. With DataRobot, Chevron can enable autonomous operations for both drones and operators. Behind the scenes, this is powered by a new class of AI infrastructure.
Here is a simulated perspective of a facility with two main production units. Across the miles of pipe and operations, field workers are essential to ensuring safe operations through the execution of daily rounds and routine operator duties. Now, let's look at how an agent, built on DataRobot's Agent Workforce Platform, co-engineered with NVIDIA, helps Chevron safely inspect and assess the site with aerial and terrestrial robots instead.
The concept leverages existing hardwired gas sensors, supplemental vision systems, and AI models to confirm a stable environment and trigger mission execution without manual hot work permitting. In simple terms, we're shifting from manually approving every mission to continuously validating that conditions are safe in real time.
Here, we have multiple agents built and deployed on DataRobot that will help predict the movement of a plume during an anomaly. One agent passes on the relevant info, like the wind speed and origin coordinates of the plume. Confirming atmospheric conditions is only the first step. We need to understand where the abnormal condition is. With greater situational awareness and insight into the probable source, the operator can easily chat with the agent to evaluate conditions. Once the agent has determined the predicted movement path of the plume, it uses this information to calculate the optimal route for the drone flight to inspect equipment. The agent passes along safety constraints associated with the gas plume movement and other parameters defined by the operator. As the drone collects imagery or video, it appears for the operator. An agent keeps drones operating in gas-free areas, protecting human staff from hazards.
This approach addresses the industry challenge of non-certified robotics hardware by shifting the focus to environmental safety assurance, thereby enabling us to reduce human intervention and accelerate robotics deployment.
Let's look at the agent workflow and how all this works. The first agent built in DataRobot uses NVIDIA Nemotron to get gas sensor information and invokes an NVIDIA Physics Nemo simulator to create plume mapping using local sensor data, including wind and other weather patterns. The agent also asks for the time horizon to predict the plume movement. Given the location of the release and current wind pattern over the facility, DataRobot's physics-informed neural network returns a forecast on how the gas plume will evolve over the next 5, 10, and 30 minutes. Then the DataRobot agent calls NVIDIA cuOpt to provide optimized drone routes to monitor the location of the release. DataRobot's guardrails and monitoring, powered by NVIDIA Nemo, ensure the agent's predicted paths for the drone adheres to Chevron's safety standards. Next, the Chevron operator inspects the suggested path before assigning the drone a safe path to inspect. They can assess the route, facility maps, and images to determine whether to add additional constraints to the route. The operator can provide this guidance interactively to the DataRobot agent via natural language chat. Once the agent takes the additional constraints from the operator, it invokes cuOpt again to find a new route. Because this is a mission-critical system, every inference and autonomous move is governed and monitored centrally with DataRobot.
This is the agentic transformation in action at Chevron, where intelligent systems perform mission-critical tasks and invent new ways of working.
Together, Chevron, DataRobot, and NVIDIA are building a smarter, safer way to power our world.